Welcome, folks. See, we've got a few people who've joined already. Just getting things cleaned up and ready to start. Okay, I think we will get started. We've got slightly lower numbers today, but I think that might be just because of the earlier start, and we'll get some people in shortly. So welcome. Today is day 17 of remote learning. That means we are almost done 6 full weeks of this. And in other news, we're also almost done the main parts of the course. So I think we have 2 more topics that I want to cover. And at that point, we'll have done all of the things that are absolutely required. There's no way you can get through grade 10 without them. All of those things will be done. And at that point, we'll be able to add a couple more things that will make grade 10 and 11 easier for you. But the good news is that when we finish up in June, you should actually be ready for grade 10. You obviously won't have had as much practice as we would normally have with a lot of the skills, but you will know all of the things you need to know. So some very good news there. So day 17, today's joke is, what did Batman say to Robin before they got in the car? Robin, get in the car. Maybe a little funnier if you've seen the Batman show. So happy Friday. Simplify that like button to show your support. Remember that on Monday, it's a holiday. This is Victoria Day long weekend. So we won't do a lesson on Monday. Our next lesson will be Wednesday, and we'll do the 10 a.m. time slot again on Wednesday and again on Friday. And we'll see how that works out. If it works well, we'll keep it. If not, then after next Friday, we'll go back to the 1 p.m. slot. But I'll keep you informed about how that's working. Our topic for today is horizontal and vertical lines. So let's jump right in. There we go. All right. So the idea here is we're going to do a little bit of an experiment. We're going to take a look at a pair of points that make up a horizontal line, and we're going to use that to give us some information that's going to really help us out here. So what I'd like you to do is start with the title of your note, horizontal and vertical lines. Let me just make sure I'm on screen here. Nope, I'm not. Ooh. And I'm not focused. There we go. Oh. Okay, there we go. Now we have the focus. Okay, so horizontal and vertical lines. And today is May the 15th. On a side note, if your family doesn't have a garden, a neat thing to try is to get a little plastic cup or some other container, and to next time you get a tomato or a cucumber or a zucchini or any vegetable with seeds in it, and you get that at the store and you eat it, keep a few of the seeds, wash them off, make sure there's nothing on the outside left, especially tomatoes. They have like a little bit of goo around the outside of the seeds. So you need to get that off, and then get some dirt from outside, put it in your container, plant the seed about as deep in the dirt as the seed is long, and see if you can grow something for this summer. So back to horizontal and vertical lines. I'd like you to pick a point, any point you want. X coordinate, Y coordinate. Maybe pick whole numbers for the coordinates just to make life a little easier, although you're welcome to pick a fraction or a decimal if you prefer. And once you have that, you can just type your coordinates into chat. Any X, Y coordinate that you want, and then type it into chat once you've got it picked. Cool. Thanks, Alan. Thanks, Owen. Thank you, Emma. All right. So Alan got in first, so I'm going to use his coordinates, 11, 4, but you can keep with whichever coordinates you want. Now I'd like you to write a second point. Oh, sorry. But for this point, you need to keep the Y coordinate the same. So I had 4 for my Y coordinate for the first one. I'm going to keep 4. If you had -7 like Jordan, then you should have -7 for both points for the Y coordinate. You can choose whatever X you want here. It doesn't matter what you pick. I'm maybe going to pick 5. So I'll give you a few seconds to do that. So if you're looking at these 2 points, one thing that's important to know is because the Y coordinates are the same, these 2 points have the same height. So I'm going to show you my 2 points here in Desmos, 11, 4 and 5, 4. Here we go. So I'll just bring this over so you can see. So there's my 2 points in Desmos, and you'll notice they have the same height because they have the same Y coordinate. And the crucial thing to know is that because they have the same height, if I draw the line going through those 2 points, it's going to be a horizontal line. So any 2 points with the same Y coordinate are at the same height, and therefore the line that goes through them is horizontal. All right, so now let's go back to the 2 points that you picked. I'd like you to go ahead and evaluate or calculate the slope of the line joining these 2 points. So find the slope of the line through these points. And you can use your points. You don't need to use the ones I've got here. As long as your 2 points have the same Y coordinate, we're in good shape. Okay, so go ahead and do that now. Once you calculate the slope, just type it in chat, m equals, and then whatever number you find. And I'm going to do it here for the 2 points that I've got. So we're doing the change in Y divided by the change in X. So once you get your slope calculated, just type it into chat. What did you get for the slope of your line? Thank you, Jordan. So for the 2 points Jordan did, he got 0 as the slope. What did the rest of you get? Owen got 0 as well. Emma also got 0. And Alan also got 0. So you're noticing everybody's getting 0. And if we look at the slope formula, that makes sense because we're going to do one y coordinate minus the other. If both y coordinates are the same number, that means we're doing minus itself. That's always going to be 0. So our numerator is always going to be 0. At that point, it doesn't matter what the denominator is, as long as it's not 0, which it can't be unless the 2 points are identical. And then you only really have 1 point. So as long as we have 2 different points with different x values, we're going to get 0 over something, and that equals 0. So all horizontal lines have a slope of 0. So now I'd like you to take the next step and go ahead and find the equation of the line. So you have 2 points, you have the slope. Can you find the y-intercept and therefore write the equation? So you can go ahead and do it. I'm going to follow it through for this one that I have here. All right. And so once you get your equation, you can type it into chat. So folks, once you have an equation, you've gone through, subbed into y equals mx plus b, solved and found the y-intercept. If you can just type the equation that you get into the chat, and then we'll keep moving from there. And if you're unsure how to do this and you'd like me to go over what I just did, if you can just type a 1 into the chat, and then I'll go through how we did this. Cool. Thank you, Jordan. All right. So I'd like you to take a look at the equation that you got. You should notice a few things. One, the slope is 0, which we were expecting because we already knew it was going to be 0. The second thing is the y-intercept is exactly the y value of your 2 points. So here my 2 points had a y value of 4. My y-intercept is 4. And that makes sense because if it's a horizontal line, it never goes up or down. So if there's a point that has a y value of 4, every single point is going to have the same y value because it's not going up, it's not going down, it's just staying the same y value for all the points. So whatever equation you got, you should see that the y-intercept is the same as the y value of both of your points. So we can draw a few conclusions here. The y-intercept of a horizontal line is the y value of any / all, because they're the same, point or points for all on the line. So since every point on the line has the same y value, that's going to include the y-intercept. So the y value of the y-intercept is going to be that number as well. All right. So let's do an example question. If we're asked to find the equation of the horizontal line through, let's say, I don't know, -5, 2. So we're given a point, and we're told to find the horizontal line that passes through that point. Well, we don't have to calculate the slope because we know the line is horizontal. If the line's horizontal, slope is automatically 0. So we can go m equals 0. We also don't have to go through and do this calculation about the y-intercept because we know every point on this line is going to have the same y value, which is 2. And that means the y-intercept, its coordinates will be 0, 2, because the y-intercept always has an x-coordinate of 0 because it's on the y-axis. And it has the same y-coordinate as all the others. And that means that our b value is always going to be 2. So there's no calculation to do here. It's horizontal, that means the slope is 0. We have a point, it's horizontal, that means the y-intercept is the same y value as the point. So therefore, the equation is y equals 0x plus 2. All done. All right. So give me a 1 in chat if that's making sense so far and you're ready to move on. If you have questions, now is the time to ask them. Thank you, Jordan. Thanks, Emma. Thank you, Revneet. All right, so if you are typing a question, feel free to complete it. I'll keep an eye on chat. But I want to move into the next stage, which is one more idea about horizontal lines that's going to unlock vertical lines for us. So if we look back here, when we did our first equation, we get y equals 0x plus 4. Well, 0 times x is always 0. It doesn't matter what number x is. X is 5, 0 times 5 is 0. If x is negative 32, 0 times negative 32 is 0. So this equation is also just y equals 0 plus 4. And 0 plus 4 is 4. So another way to write this equation is just to write y equals 4. And in fact, that's how we're usually going to do it. Usually we won't write out the full version, we'll write the simplified version, y equals 4. This is useful to us in two ways. The first is it kind of confirms the idea that we had that all the points on the line have the same y value, and it's 4. One way to think of this equation, y equals 4, is it's saying the y coordinate of every point is 4. So if we look at the one you just did, you can simplify that one as well. So here's 0 times x is 0. 0 plus 2 is 2. So this equation, we could write it as y equals 2. And that's telling me every point on this line has a y coordinate of 2. And every point with a y coordinate of 2 is part of this line. They are one and the same. Okay, so you might be saying, all right, that makes sense, but why is that useful? It turns out it's critically useful, absolutely required to understand what happens with vertical lines. So, vertical lines is going to be our next topic here. And again, you can choose any pair of points that you want, but you need to choose the same x value. So I'm just going to scroll up. Alan gave us the first point here. Owen gave us the second. He said 2, 5 at the top of the chat there. So I'm going to use that one. And I'm going to choose the same x value, so also 2 and maybe 7. Doesn't matter what y value you pick. So if you have 2 points with the same x value, and now we go and we calculate the slope, we're going to see that we get a problem. So I have y final minus y initial to get the change in y, x final minus x initial to get the change in x. Y final is 7, y initial is 5. Whoop, 5. X final is 2, x initial is 2, and that gives me 2 divided by 0. And lots of people make the mistake of thinking that this is 0. It is not 0. Try it on your calculator. 2 divided by 0 equals, and we get error. Divide by 0, error. All right. We can't divide by 0. It doesn't make sense. If somebody says, I have 4 fingers on my hand, can you split them up into 0 groups? You're like, no, there's fingers there. They have to be at least one group. There's no way to split them into 0 groups. Same thing if I asked you, I have 4 fingers. Can you split them into groups that have 0 fingers in each? Well, no, if all the groups have 0 fingers in them, then you're going to have 4 fingers left over. You haven't split anything up. So we can't divide by 0. There's no number that's equal to the result of this. So some calculators will, instead of saying error, they will say undefined. And that's what we're going to call the slope of a vertical line. So slope of a vertical line is undefined. All right, so horizontal line, slope is always 0. Vertical line, slope is always undefined. We can't calculate it to a number. How do we know it's always going to be that way? Well, if the two x values are the same, that means the points are one on top of the other, right? Two x values being the same means the points are one on top of each other. We're going to get a vertical line. And the two x values being the same in the slope formula means on the bottom you're doing something subtracted by itself. And that's always going to give us 0 in the denominator. So we're always going to get a divide by 0 error. And therefore the slope is always going to be undefined if the line is vertical. Okay, I'm going to pause here for questions. If that's making sense to you so far, give me a 1 in the chat. If you have a question to ask, go right ahead. This is one of the weirder topics that we do in this course. A lot of people find it very confusing the first time through because it's so different from a lot of the other things that we've done. So I'll give you a bit of time, ask a question, or type 1 in the chat if you don't have any questions. Thank you, Alan. Thank you, Emma. Jordan, for vertical lines, is this always the case? Great question. Yes. So as long as we have a vertical line, and maybe I'll try and show it on Desmos, but anytime we have a vertical line and we pick 2 points on the line, the x value of those 2 points has to be the same because the vertical line doesn't move sideways at all, right? It just goes straight up and down. So whatever the x value is of 1 point on that line, if I only move straight up or straight down, my x value isn't going to change. So both points on the line will always have the same x value for any 2 points you pick. So if it's a vertical line, I'm going to have the same x value for any 2 points I pick from that line. And that means when I go here and I do my slope calculation, the x values on the bottom in the denominator are both going to be the same, right? 2 and 2. Here we go. And if I do a number subtract itself, I'm always going to get 0, right? If this is 5 minus 5, that's 0. If this is -3 minus -3, that's 0. So I'm always going to get this divide by 0, and vertical lines are always going to be undefined. So hopefully that answers your question, Jordan. Thanks for asking it. All right, I want to show you the last piece of this now, which is how do we find the slope, or how do we find, pardon me, the equation of a vertical line. So I'm going to rewrite the same 2 points. Cool, thanks, Jordan. Glad it worked out. So we had 2, 5, and 2, 7. 2, 5, and 2, 7. And we said, okay, the slope here is undefined. That means we can't use y equals mx plus b. This form works for every kind of line except vertical lines. Vertical lines, we can't do this. And the reason we can't, because m is not a number. It's just undefined. And writing y equals undefined x plus 7 doesn't really make any sense, right? How are we going to multiply x times undefined? We can't do that. There's another reason it actually doesn't make sense to do this. which is that if we have a vertical line, and I'm going to create one on Desmos for you. So you can see it here. If we have a vertical line, what's the y-intercept? Well, it never crosses the y-axis, right? It doesn't go sideways at all. It just goes straight up and down. So it's never going to get over to the y-axis. So there isn't going to be a y-intercept. When I say that, a lot of times students think that means the y-intercept is 0. The y-intercept is 0 would mean that this line crosses the y-axis here at 0. That's clearly not the case, right? The line's not going through this point. So when we say there is no y-intercept, that's totally different from saying the y-intercept is 0. It's not that it's 0, it's that it doesn't exist. There isn't any number that is the y-intercept of a vertical line. Okay, so we've now established that vertical lines are really different. The slope is undefined and the y-intercept does not exist. There is no y-intercept. It does not cross the y-axis anywhere. So there is no number, not even 0, that works as the y-intercept. So this y equals mx plus b, not useful for horizontal lines. Great for everything else, but for vertical lines. But for vertical lines, this is no good. It doesn't work at all. So how can we write an equation for a vertical line? Well, the key is that idea we had about the horizontal line, where we said, hey, for a horizontal line that passes through a point with a y value of 2, we can just write y equals 2, because that says that every point on this line has a y value of 2. Well, we can do the same thing for vertical lines. And again, I'll show you the Desmos here. Every single point on this line has an x value of 5. Right? This one is 5, 1, because the y value is 1. This one up here is 5 for my x, 7 for my y. This one up here is 5 for my x, 9 for my y. No matter which one I pick, like down here, still 5 for my x, -3 for my y. They're all going to have 5 as the x value. And that means that we can write the equation of a vertical line by just saying the x value is 2, and that's true for every point. Every point with an x value of 2 is part of this line. Every point on this line has an x value of 2, so x equals 2 totally defines the line. And you can try writing x equals 2 in Desmos, and you'll see that you do indeed get a vertical line through both of these points, 2, 5 and 2, 7. So that's going to be our trick. We're going to be able to write equations for vertical lines even though the slope is undefined and the y-intercept doesn't exist, by just saying, okay, every point on that line has the same x coordinate, so I'm just going to write x equals whatever that number is. So let me do a quick example, and in the meantime, if you have questions, you can start writing them in. Oops, sorry, of a vertical line through, and I'll pick up a point from the chat here. So up at the top, Alan said 11.4, Owen said 2.5, and Emma said 3.4. So we use that one. So this is super fast. The answer is x equals 3. Done. Don't have to do any calculations. I know it's a vertical line, so the x coordinate is always the same. So I'm just going to go x equals. And then what is that x coordinate? Well, if it's always the same, and one of the points it's 3, it has to be 3 for all of them. So just x equals 3. All right, so these questions, there's a lot of thinking that happens to understand them, but actually doing them is super fast and easy. All right, so just give me a 1 in the chat if that's making sense to you, and a question if you have a question. And then we're going to talk about one last topic before we wind up the stream. Thank you, Emma. Thanks, Alan. Thanks, Revneet. All right, so I'm going to keep an eye open for questions. I just want to talk about the very last thing. In the handout that's for homework, there are 14 questions. It should probably take you like 5 to 10 minutes max. And as you can see, for most of these questions, you're just writing y equals a number or x equals a number. That's it. There's no other calculation. So these questions are pretty fast. The one thing we haven't talked about that you'll see is if I have an xy plane and I have a vertical line somewhere, what kind of line is perpendicular to my vertical line? Well, let's draw it in. That's perpendicular. And it's a horizontal line. So if you're talking about parallel or perpendicular, normally we have to know, okay, two lines that are parallel have the same slope. Two lines that are perpendicular, well, we take the slope, we flip it, and we change the sign. So normal lines that aren't horizontal or vertical, we need to do a little bit of calculating to figure out parallel and perpendicular, or at least perpendicular. For horizontal and vertical lines, we don't need to do that. If a line is horizontal, the parallel line is going to be horizontal, and the perpendicular line is going to be a vertical line. If a line is vertical, the parallel line is also vertical, and the perpendicular line is horizontal. So if a question asks you, here's a line x equals 5, so find, let's do an example, example 3, pardon me, example 3, find a line perpendicular to y equals 7 that passes through let's go 8, -1. All right, so this looks like, oh my gosh, super complicated question. It's actually not. We just need to be a little thoughtful. Y equals 7, that is a horizontal line. So what kind of line is perpendicular to horizontal line y equals 7? Well, that's going to be a vertical line. So the line I'm trying to find is a vertical line. That means its equation is x equals a number, and the number is the x coordinate of any point on the line, because they're all the same. Well, that means if it goes through 8, -1, one of the points has an x coordinate of 8, therefore they all have an x coordinate of 8. Done. All right, so don't be thinking if it's perpendicular, I need to do 1 over and flip and change the sign and so on. That's true for regular lines, but if they're parallel or if they're horizontal or vertical, it's super easy. We just go, oh, horizontal, well, perpendicular, that means I'm looking for vertical. So it's going to be x equals. All right, if this was said parallel instead of perpendicular, then I would just go y equals -1, because parallel to a horizontal line is also horizontal. So the equation is going to be y equals, and the value is going to be the y coordinate of any point. All right, so that wraps up the stream. Give the questions in the classroom a try, and I'll stick around here for a minute or two to see if you have any questions. If you don't, if you can just type a 1 in the chat so that I know that we're all good. And if you do, type them into the chat. I'm happy to answer them. Thank you, Alan. Thank you, Emma. Let's see if we can get a few more people. Thanks, Ravneet. Okay, before people leave, I just want to say a couple things. One, quick reminder, no lesson on Monday. Yes, Jackson, I'll check my email after the stream. So no lesson on Monday. If you can spread the word to your classmates that we're doing the 10 a.m. stream time, I'm hoping that for some of you it will work out better than 1 p.m. So if you can let people know that, that would be really appreciated. We'll try to get as many people in here as we can. All right, folks, that's it for today's stream. Have a great rest of your day. Enjoy your long weekend, and we'll see you on Wednesday.